Respected guests, professionals, student execom members, RAS SB leads, and dear attendees, good evening, all. We hope you all are doing well and staying safe. Before we start off with the program, I would like to request all the attendees to stay with us in the session till the virtual photo session at last. Without any delays, let's begin. IEEE RAS Kerala chapter is up with the second session of the accelerating talk series, The Robo Crewtales, where eminent women engineers from the robotics domain engage and enlighten us with their professional experiences. I invite Jiva to deliver the welcome address. On to you, Jiva.
Thank you, Anne. Good evening, everyone. It gives me immense pleasure to welcome and introduce our distinguished resource person of the day, Pallavi Saha ma'am, the co-founder and the CEO at RigBetel Labs. She is a tech enthusiast whose company works in the space of industrial robotics and automation. She also has experience in diverse domains like mobile application development, cloud technology, and computer networking. Apart from the tech based role, she is also adequate in operations, management, and marketing sides of RigBetel Labs. Amidst your busy schedule, we sincerely thank you for being with us in this session to encourage the gathering with your valuable words. I hand over the mic to you, ma'am.
Thank you so much for the introduction, Jiva, and thank you everybody for having me and taking your time to join this session here. Jiva has been trying to get a hold of me since long, and unfortunately, I wasn't able to comment before. So yeah, thanks for staying patient on that. What I am sure for today is not something that Okay, now you know how to run ROS commands, and now you know how to make a robot, but rather I'm sure to give a picture from more or less a hiring perspective or the management perspective of a robotics company and the domain in general, along with touching a few things about what does the present look like and what does the future look like, and how can we be a little future ready at least for the world of robotics in the coming years. So I'll just share my screen. And folks, I'll be sharing my screen from a different device than my camera one. So pardon me if you find me looking onto another screen at times. It's just my laptop on the other end. So yeah, I'll just start doing that. And just let me know once you can share see my screen. Visible, everybody?
Yes, ma'am.
Okay, great. So you might have read in the posters as well, the topic says future of robotics from warehouse to house. Now, it might sound like a poetic or rhyme kind of a topic to say it from warehouse to house, but I have a reason behind that too, and I'll come to that in the later part of this session today. To briefly start with who am I and why would my opinion really be something that you should or you might consider in your journey in the robotics industry as well. So I'm, as said, the co-founder and CEO of RigBetel Labs. I'll give a brief about RigBetel Labs further, but about me, I'm a 23-year-old software engineer by profession. So again, I am an IT person working in the mechanical or not so very IT industry actually, and very enthusiastic about robots since day one. So as soon as I started my engineering, I've had a good amount of people around me who've been working with robots or have been around robots, let's say, and that kind of led to the increase in the enthusiasm as well. Apart from that, I finished my engineering. I worked with TCS for a year as a software engineer, and that also gave a bit of the corporate experience, or what's the pros and cons of the corporate, and I'd like to bring that to my ahead journey as being an entrepreneur as well. Apart from that, in terms of the academics, as expected, I am slightly, or let's say I was a little good with college days. So I was one of the gold medalists of my batch for the particular year. And rest apart, I love to talk. You might have realized that by now. I speak very fast. So if you feel that I'm going really fast and you're not able to catch on to my words, just drop a message in the chat and I'll try and slow down my pace on that. I love sharing stories of my own life, my own experiences, what we do as a company, and what the industry in general looks like. Rest apart, an entrepreneur in making. It's just been about 3 years of RigBetel Labs. We've been through a lot of ups and downs, learned a lot of new things. And yeah, every day I just live around experts in the field, right? From my internal team to my clients to the other experts and advisors that we meet on the way. So I hope I gave a brief about who am I and where does my opinion and experience comes from. A bit about RigBetel Labs as to what we do. So to the core, we're a service-based company operating in the robotics domain, ROS being our field of expertise and the most dominated field as of now in our business. And apart from that, there is a small vertical that we run, which is in the education domain. So we do have a certain set of very personalized and very limited amount of training programs, which we do so that we can furnish the skill requirements of our own internal team as well as the clients that we work with. And yeah, apart from that, we've been working with national and international companies for about 2.5 years now, and in multiple domains. So it's not just in industrial robots, we've been making social robots, we've been making robots of all sizes and capacities for a very different array of use cases, right? From being into warehouses to being into shopping malls and being in exhibition centers. We've made robots of a good amount of diversity there. A brief about the vision and mission as to what are we trying to achieve here. So we have a different set of goals for both of our clientele, right from the industries as well as the educational side, which includes universities as well as students. The major goal being we want to kind of bridge the gap that right now exists amongst the student community or amongst people like us who just graduated from college, but now we have no idea as to what's happening on earth and what's happening in the industry. We want to bridge that gap really so that the student community comes to know about the most amount of things of the industry and probably to have lesser talks like these where you have to come to a very different talk altogether or a very different event altogether to come to know about what the industry is doing, right? So that's the major aim that we can say we're trying to work through. Now, coming to our thing for today, and what do I have to speak about robotics? You'd be confused a little bit. We're sure for robots. Why do I see history of computers here? But I have a little of an analogy that would help you guys to kind of link through as to what's the journey going to be like and what do we expect out of the public right there. So, to take this analogy back to about the 1940s or 1950s, where we had huge computers or supercomputers, as we used to call it, and generally people in the defense agencies used to have access to it. So back then, computer, the word itself is a very heavy term, right? We were hardly aware as to how do we really use them. Now, for people born like post the 2000s or 2002s and stuff, you might not be very aware of the era where we did not have PCs at home. Rather, people used to go to cyber cafes and operate from IT labs in schools and colleges. So there was that time as well, right? But then that's when the IT boom happened. So since we came from supercomputers to mini computers, then to home desktops, then we came to laptops, and now we have a smartwatch, a smartphone, or tablets in every hand that you see, right? From a 10-year-old to now a 60-year-old person has access to some or the other smart device, right? And since we had access to these things, we had access to internet, that's how we were able to work on it more. Had it been limited to only the MNCs or only the defense agencies or only to big companies who had immense amount of money to invest in the infrastructure, we might not have known about IT or computers or software engineering that much. Not every other YouTube channel would have been teaching you how to code in Python and how to code in C++, right? Because that market wouldn't have existed altogether. So that's the exact point that I'm trying to make sure that since we had access to the infrastructure, we were able to develop our own skills as well to match that. But then there were people who helped this transition happen, right? There were people who worked towards this transition happen. With the robotics industry, if we see where are we as an industry right now, not just with robotics, but in general as the revolution goes by, we're currently at the state of Industry 4.0, right? We keep hearing this term every now and then. That, oh, it's Industry 4.0, you have to work on these new skills, you have these new technologies in the market. There are so many aspects that we're going around. So we are at the stage where we now have the power in hand that, okay, we can make robots in a way that it's very, very accessible to every person out there who's enthusiastic about it. So if you choose to be in the domain of robotics, the entry barrier for you shouldn't be as high that you probably lose hope in a couple of months. So that's where the stage that we are in, right? So to give a little bit of the history as to what people did before to come to this stage and what are we required to do to get on to the next stage where probably every person could have a robot, every house could have a robot. There's a huge scope of opportunity there. So we all know, right? Robotics has a very ancient history, let's say. It's not there just in like 10, 15 years or whatever. It exists since 1900s, 1920s to be specific, where we actually coined the term robot. So this was from a play where it's more or less just a tin can structure that could actually move, was what we called as a robot. So it actually meant as a slave, if we see from a language translation perspective. Let's not get into that right now. But to give a history on that, that's how then we progress. So a couple of industries tried to get into it. Toyota, companies like Honda and these guys started to get into the industry. They tried to automate some of their production lines to kind of get things done faster at a good pace. So more or less, they pioneered the industrial robotics section, right? So that's when we came from slightly the industry 1.0 to the industry 2.0 kind of a stage, or from 2.0 to 3.0 kind of a stage. So that evolution happened really slow, right? It took up them around what, 80 years or so to get robots on a stage that, okay, now they're used in multiple segments. They're not just there for one particular skill. So if you see on the nitty-gritties of it as to, okay, what did they do that helped them to get into this transition? So if I'll go a slide behind, we started with a tin can structure, right? So who can make a tin can structure? A tin can structure can be made by any craftsman who knows how to operate with metals, who knows how to kind of bend stuff, get it into a particular shape. That's where it started from. Then once we knew that, okay, since the revolution of cars started happening in the similar duration, so we were now aware that, okay, we can create energy. So that's when the scientists came in. So you see what's happening. We had a craftsman who could operate with metal stuff. Now we have a scientist. And these two together, they actually tried that, okay, we can generate electricity, generate energy. Let's give it a shape and a form factor. So in today's day and world, if we translate it, that came in as mechanical engineers and electronics people or the electrical people coming in and trying to make a machine together, right? That's where the progress started from. Then when we moved on to things like a Mars rover or a manipulator or something that could operate as a hand, like a human hand, there have been involvements of doctors too in this to help understand that, okay, how does a human hand move? So I replicate how a human hand moves using mechanical and electronics components. So back then, if you knew, okay, how does a motor work? If you knew how does mechanics work, if you know a bit about the electronic components and things like that, great, you could make a robot. Although those skills themselves were on a very minimum end, like not everybody had access to it. You have to be a very sharp scholar mind person to actually go and study into a good university, get resources to learn, and then make things like these. But today we have the power of internet, right? We have, okay, tomorrow if I want to that I might want to make something that looks like the Curiosity rover or a Mars rover or something like that. I can just Google up stuff like, okay, this is how a rover is made. These are the electronic components that are required. And this is how assemble it, or this is how the design should look like. And I can get a hold of it, right? So although it's on the good side, that yes, we know we can get access to resources, but then everybody has access to these resources, right? Everybody in this meeting, everybody in your college, everybody in the country right now has access to these resources. So how do you differentiate yourself that apart from these resources, I also know this, and hence I am at a better position to either develop a product, land a job, or maybe try and do something of myself. That could be any aspirations that you're looking at. So, for that exact reason, is where we come to the more modern age robots. So, I think we've seen almost all of these robots all around the internet, right? We've seen about Sophia. She got a whole nationality thing done. She's been on a tour around the world, meeting people, interacting with them. And yeah, I don't know how many of you have seen her and how many have interacted with Sophia, but she is very human-like. The voice is very human-like. The body movement is very human-like. So how did that transition happen? So already there were mechanical folks, already there were electronics folks. Then came in folks who knew software, who could make AI and ML models to train them on data and get a certain output out of it, which is more close to how humans could behave, right? So these three together, okay, now I can actually make it. Now I can actually work on a robot and make it like Sophia. Then it comes in like examples like our Boston Dynamics robots. They have bipeds, they have quadrupeds. They've been working on it since 10 years. So there has to be something that took them 10 years, right? So right from the configuration for it. So if the mechanical folks here, you guys would be very well aware about how the kinematics parts work, right? But to get that kinematics to be that accurate is where we need to focus. You'd find information about kinematics all over the internet, but how to tune it, how to make it work for a specific instance is what you'd need to learn well. And how do you learn that well is obviously more and more practice. It has to be more and more projects that you make. Now, with robotics in general, as I said, right, not every student has access to a robot. That's where Arduino boards came in. They helped us to, okay, it's a cheap board. Every student can try and get an access to it, try and build things through that. But then came in the break that, oh, the industry doesn't use Arduino all day, right? We have to learn in more things. So how does that part work then? Fine. I know how to work with an Arduino. I know the basics. Now I can just apply the logic set. So there are these two categories of engineers that we find, right? The first category being people who can, for example, if I take Arduino again, they've not just copied and pasted code from the internet. Rather, they've learned the logic of how to build it. So now nobody can take the logic out of them. Tomorrow you give them a Jetson Nano board. Tomorrow you give them some industrial computer to work with. Since their logic is right here, they can work with it. But then there's the second category of people too. Okay, I can buy a project since I want marks for it. Or I get a project, I just copy the code, I implement it, I show it in the demo, I get marks and done. My semester is over. And this might seem a little more on the philosophical end. But as said, there are hundreds of people trying to teach you how to learn robotics, trying to teach you how to code, but then it's all upon you, or there has to be somebody bombarding you that, okay, you learn the logics, you don't learn the syntax, or you don't just rote learn everything. Okay, I got a bit deviated from my topic really. So yeah, that's where the evolution came in. And now this is where we are, right? This is where we are currently. We know of AMRs, we know of AGVs, we know of industrial robot arms with companies like ABB, Fanuc, on these huge, massive robots working on production lines. If you're interested in any of these categories, just put up the name, try finding the industries that work with this, and you'll find how much progress they've made. Now, again, if I categorize who made this progress here. So these systems initially they used to work on PLC based systems, or they used to work on industrial computers where everything is very, very hard coded for a particular work. So if an arm is supposed to do spot welding somewhere, it knows that okay, these are the 4 points I have to weld. I start from here, go to second point, go to third point, go to fourth point. Done. The arm has no intelligence of its own. And of course, there's no problem with the system, right? Why not? Huge manufacturers like the Tatas, the Suzuki, or Mahindra and companies like these, they have huge amount of money and they can put that amount of money in their manufacturing plants. So then why the revolution was required? Because there was this sector in the market who required robots to do multiple tasks. Now, can I just sit and program the robot every time I need to do a task? No, right? That's where the automation part came into picture. And we segregated the people who knew the computer part of robots or the coding part of robots into two different categories. One who could make the hard code programs or the very specific algorithms, and the second section who could make just autonomous systems altogether. That, okay, I make a software as such that my robot arm is capable of moving from point A to point B. Now, it could be any point. So, what's the end task that remains with the user is you have to define point A and define point B. Right? That's where the evolution again happened. So who were these skill sets? These skill sets were people who now knew some part of mechanical as well. So they know how that particular motor is going to work or how that particular kinematics is going to happen. And then they just automated that kinematics with the coding language or the programming language that they knew of. So you see how the transition happened. And if you observe with the education system too, the transition has happened in a similar way. We had folks from mechanical and we had electronics as a separate branch. Then we had CS, which had integration of mechanical components. Now we have this field called mechatronics. I believe a good amount of you might be studying that, or you know colleges which offer mechatronics degrees. And what were they? They were mechatronics was mechanical, electronics, and computer science together. Now, I think in the last 2 years or so, I have seen institutions wherein you have mechatronics with specialization in robotics. That can also be bifurcated ahead that you specialize only in manipulators or only in mobile robots or only in aerial robotics. Why? Because the field is expanding that way, right? Similar if you go to underwater robots, for example, you go to aerial robots, for example. So one common misconception that I've seen amongst robotics enthusiasts recently is that I need to know how everything works. I need to know how a drone works. I need to know how a manipulator works, or I need to know how an AGV system would work like. But it's actually not necessary. If you can, if you have that amount of time and energy and effort that you can put in and understand everything, great. But that is not the base requirement for you to get started in the industry. Because there are hundreds of opportunities waiting just for manipulator or just for UAVs or just for AMRs and AGVs too, right? So that is one misconception. If anybody from the audience has this, you can very easily let go of that. Just specialize into one main thing that you know and you'll be fine. I think there's this saying, right? To be a master of all. So who do you want to be? You want to be the master of all, or you want to be the jack of all trades? I say be a mix of both. How many ever you can know, good. But in the end, if today I am also to hire somebody, the last question that I'll ask is, fine, you all know these, let's say 10 things, but which is that one thing that you're most confident about? So find that one in the industrial robots, find that one segment that, okay, this is what I'm the most confident about. And then I work through that. Now, for resources, there are n number of open source resources available, particularly for arms and things like that. We have universal robots. They have immense amount of resources, immense amount of codes and GitHub repositories available. Try and have a look with it. We have a ton of move it packages available. There are more and more new updates with the community happening every day with it. So again, too much resources to refer to, right? You can pretty much go to one topic at a time, take it ahead. Similarly, if you go for UAVs, again, there are n number of resources available. Now, pivoting a little bit from the industrial robotics to the social robot section. Why am I saying this pivot is required, or why did this pivot in general even happen? Is the same computers and analogy, right? That okay, every person needs to have an access to the computer to kind of have an in-depth knowledge on it or in-depth experience with it. So does that mean that if I have a robot in my house, I can just disassemble it all together and learn how a robot is made? Well, that's upon you because if I have a robot in my house, I might as well disassemble it if I've not made it. So yeah, that's upon you. But the in general aspect being, if people are aware about robots, they will tend to look on it more. They will tend to work on it more. And that's how the industry expands, right? So if talking about social robots, where are we or how did it start? I think Pepper Robot is one of the very pioneering robots in social robots. We've seen a good amount of videos about this. A lot of museums have this robot. So it works on AI. It can detect your face. It can talk to you. It can give us certain actions. It can move from one place to another as well. So again, an industrial AMR could also move from one place to another, right? The same stack of people using the same stack of knowledge, I can make a moving robot. Why not make it look a little better? And that's where the craftsman from right the 1920s came back into picture that okay, I have to make a structure that looks good. Now I use the concepts that I know from making industrial manipulators or making industrial AMRs or moving robots in general. Just put them all together and you're done. Right? So you see the skills array there, it still remains the same. It's just the extra and a bit of specialization that you do in mixing things together. Right? Again, the rest of the ones that you see here too, the emo robot, it seem to be one of the very cute robots, just a desk-sized one. You can pet with it, you can play with it, it will just display emotions, even like crying. So do you expect a robot to cry? No, right? Is it crying actually? No. What's happening is just an LCD blinking with two LEDs right there. Or it's just a sensor that detected that you touched it and it's responding in a certain way. But the way to show that crime was just a way of presenting. So now the whole point of drawing to this part was that today, if you're coming in the robotics sector as an employee or as a founder or as a person who wants to develop a new product, point number one, get your basics very clear that, okay, this is how I make a moving robot. This is how I make a moving manipulator, whichever sector you're more inclined towards. That particular robot now, then think of which market do I want to target. Or if you are working on a particular product, especially as an employee or as an intern, you already know what the product is supposed to be, right? The product research, market research is already done. So the next skill that comes in is, okay, how do I present it well? Even industrial AMRs these days, they look very classy. They have beautiful lights, they have beautiful finishes. Is that required in a factory setup? No, it's not. But it's just a new trend that's coming in. So right now, if you're in your first year, if you're in your second year, or already in a very nice time period of your engineering, which kind of gives you that, okay, I have enough time to practice on things. I have enough time to learn new features, learn about new tech, and maybe until you graduate, there's going to be another wave of a different, very different kind of robots, maybe some mix of industrial and social robots mixed together, or something like okay, I have a desk-sized robot that can also do this task. You never know, right? But the basics are still going to remain the same, which were there right back in 1950s. It's just an upgraded version. So I hope I could make my point here. I know the discussion wasn't very much on the technical end, but this was from a perspective of okay, if I am hiring somebody tomorrow, these are the things that I want to consider that okay, you know the basics, you know one particular thing to the very best level that you can, you know how to take things forward, you know how to upgrade yourself. So I hope I was making my point clear. It was a very short presentation, so I'll be open to most amount of questions that you guys have. And if the panel members too have any questions, please go ahead. People, any questions? It can be technical, it can be non-technical. You're more than open to it. We have around 20 minutes of time and we have a good 60, 65 people in the call right now. So, yeah, any questions? Go ahead, please. Did I bore everybody to sleep here? At least let me know that you're awake. Even a hi or a hello in the chat could work. Just let me know that you're awake.
Hi, ma'am. My name is Aditya. So,
Hi,
what are the
Aditya.
future projects? What are the future projects of RigBetel Labs?
We actually have a very diverse future, if you say. So, as of this point, we are actively working in both industrial robots as well as social robots. For social robots, we have delivered a couple of units in the last 1 month. So, right now, what we're working at is enhancing the user experience. So, it's more on the software end. And for the industrial robots, we're currently working on migrating a good amount of our things from ROS 1 to ROS 2 to kind of be ready in a couple of years to come. Any other questions, folks?
Good evening,
Viva,
ma'am.
you guys there? Yes, Abhiram, tell me.
Ma'am. Ma'am, my name is Abhiram. I'm from Marathaneshes College, MA College, Kodamangalam.
Yeah.
So I was wondering if we can, students can go for internships at your company, like at RigBetel Labs, or what are the opportunities for students who are just graduating? Can for this type of internships, what should they like look forward into? What should they focus on to get into this field of robotics and industrial robotics?
Right. So, see, there are two stages in this. Either you have no idea about robotics, then there's a different roadmap that you could possibly follow. Or if you have an idea, if you've worked on a couple of projects through your engineering degree or through your 4 years of engineering, then there's a different roadmap. I'll start with the second one first. So, if you have a basic idea that, okay, this is how a robot works, I know a bit of the mechanical components, bit of the electronics components, then try and first find what is the next step that you want to go in. Do you want to go into actual industrial robots and the ones that used to work on PLC systems, and because they're still in abundance in the industry. The second possible option could be that, okay, I want to move towards ROS development. So how would autonomous mapping and navigation and things like that would work on a particular ROS-based robot? Or you move on to the entirely software section of it where people make now web interfaces or just make a particular vision-based algorithm to develop a certain thing. So that this will be kind of on your interest part. Which way are you more inclined towards? Is it the design? Is it the electronics? Or is it the computer part? Depending on that, you have a lot of companies right now in the market who are looking for more and more interns because their work is on a very high note. They have huge loads of work, but not enough people to actually hire and get working on. So that way you can work with, in terms of working with us, we as well hire interns on huge numbers and employees on a good numbers as well. But again, everybody has a criteria, right? We also have a criteria that you should know at least some basics of ROS so that at the start, maybe there isn't a requirement of 5 months, 6 months of training. Within a month or so, you should be good to start with whatever the task at hand is. Or if you're going with a particular product-based companies too, the south of India is hugely concentrated with companies who are manufacturing AMRs or electronic components or individual components for making AMRs and manipulators. Right? So for them too, there's a particular module that they're working at. If you can contribute to it, they'd be more than happy to hire. The hiring is more focused towards the third and fourth year of engineering students at this moment, at least for if you'd say about the startup industry. Reason being, they're a little more mature on their work set. So that doesn't mean that people from their first year and second year have nothing to do. You have actually much more things to do so that your third and fourth years become easy. One thing is you can intern at primary companies who are manufacturing parts of the entire robot. Now, it could be any part, software part, mechanical part, electronics part, where they have a repetitive task to be done. They actually don't bother about your skill set a lot. But that gives you one very huge idea of how that particular module is working. That makes you the master of that trade. And since you see all other people are working around you on different senior level tasks too, that gives you an idea, which helps you choose how you can go ahead. So yeah, I hope I answered your question, or if there's any follow-up, go ahead.
Thank you.
Okay, cool. Who's next?
Hi, ma'am.
Hi, Jiva, tell me.
Ma'am, I would like to know how did you raise this funding during your initial stage of the startup?
Okay. So I'm not sure if this is on the good side or the bad side, but we're a bootstrapped company, a very happily bootstrapped one. So we haven't raised any outside funding till date. Neither have we taken in any bank loans or debt from HNIs or things like that. But the way that we could survive was simply because we were in the service industry already. So service industry is something that you do not need to spend huge on the marketing costs or on procuring inventory and things like that. You just serve a particular client, get the money from that, put it in the next development, and that works. So that is how even so what we generally do is we dedicate a certain amount of our entire budget into R&D so that we can have our product line in the sides too. The way we developed AutoSpot, the way we developed our own research platforms as well, was very much from the same amount of profits and money that we got from the service industry.
Okay, ma'am.
Are there any folks here who have been working already? Like for 6 months, 1 year, 3 months, 4 months, whatever. You've been working through an internship or through a job in a robotics company or something close to robotics.
Ma'am,
Anybody? Yeah. Yes, Diva, go ahead.
The majority of the participants right here are students.
Hmm.
We haven't
Okay,
invited any working professionals or someone.
got it. No worry. That gives a better actually insight as well, right? So I'll focus more about how to get to that stage and rather not how to go ahead from that stage. Yeah.
Yes, ma'am.
Good. Anybody else? Either I was way too good with my explanations, or you guys came with no expectations or no questions at all. So which was the case? Like you just did not have any questions in the start about how the industry is, what is happening, what could be your next step. Then had I been you, I would have been curious with hundreds of questions. So I'm hoping a couple of from this panel too.
Ma'am, most of the students are not just giving their baby steps in field of robotics, so they might not have really good questions right now. Maybe you
No
could have,
worries.
yeah.
No worries. That's fine too. I mean, even if you're starting, it's a very good span to be in to start with robotics. So yeah, it's not going anywhere for the next 15, 20 years to come. It's ample of opportunities to work around. In any ways, the organizing team, I'm done with my set of presentation and my set of the talk. So if you guys have anything, we can go ahead with it, else we're good to close the session for the day.
Thank you, ma'am. That was indeed a noteworthy session. It was really informative, and I hope that has had a very great experience. Thank you so much. Before we move on to the conclusion of the event, I request all of you to just switch on your cameras so that we can have a good snap to keep it as a beautiful memoir. Attendees,
Come on, people, that's your last chance to show that you are not sleepy. And I did not really bore you to sleep. So people who are awake, let's see your faces for a couple of seconds so that we can have a good picture to frame.
Thank you all. Now let me invite Amrita to propose the vote of thanks. On to you, Amrita.
So thank you so much, Anne. Very distinguished resource person of the session, Ms. Pallavi Saha. It's my pleasure to thank you for presenting us with such a wonderful session. And thank you so much for answering the queries of the attendees and giving them insights about various phases of robotics. On the behalf of IEEE Kerala chapter, we extend our heartfelt gratitude to you. Thank you so much for sparing your valuable time in guiding our attendees through the best. Thank you so much, ma'am. So
Most
now,
welcome. It was my pleasure being here. And after a very long time, I've delivered a session of this sort. So people are open to all feedbacks that you might have. If you think there are points that I've missed, do let me know. Either you can send me an email or ping me on LinkedIn, and I'd love to include those points in my further sessions.
sure, ma'am. We'll let you know. So, yeah. Now, let me take a moment to extend our gratitude to the members of the Professional Lexicon, the student team, the ROSSB leads, and the student volunteers of IEEE Kerala chapter who have stood as an independable support, working hard behind the scenes to make the session a grand success. Lastly, but most importantly, thank you all the attendees for the valuable present and enthusiastic participation. We hope that you all have had a great time.
Thank you, Amrita. I request all the attendees to kindly fill the feedback form posted in the chat box without any fail. I repeat, I request all the attendees to kindly fill the feedback form posted in the chat box without any fail. Thank you all for joining us today. Hope to see you all for the upcoming events. Till then, stay connected with us. IEEE RAS Kerala chapter. This is IEEE RAS Kerala chapter signing off for now. Thank you.
Thank you, everybody. Good night and stay safe.